Hey everybody, this is Larry. This is me trying to do Q3 of the weekly contest for 65, maximum product of 2 integers with no common bits. Hit the like button, hit the subscribe button, join me on Discord. Let me know what you think about this one. So this one, I honestly, I would say this one is annoying. Because given the constraints, I, I, I had two ideas immediately. One was, which I know to be the correct one, was the DP one, which we'll go over in a bit. No pun intended. The other that came to me a little bit was the idea of a try. I missed it because I guess I was thinking about more. I forget what there's a similar problem with the try that greedy works, and as a result of greedy works, maybe it's XOR or something, like maximum XOR or something like that. But I was trying to use the same logic, but it just turns out that there are cases where it doesn't work because if you're doing a greedy thing, the greedy just gets you to the wrong place, which is fair enough. Didn't do it. And also, honestly, so as a result, after that, I spent a long time just kind of trying to figure out how to solve it. I even had the DP solution up, but I just didn't finish it because I didn't think it'd be fast enough. What got me to finally finishing was that I didn't finish Q4, so I didn't even start Q4 really. So I was like, all right, let me try Q4. Let me just YOLO submit this. Let me just finish this. It'll take me like 2 minutes to type it out, and then it worked. So yeah, awkward. I mean, I had to make one more optimization, but otherwise it worked, and I was in Python in 16 seconds, which is just shenanigans. It is yeah. I mean, given these constraints, I wouldn't expect it to work, but especially because of the thing about how they measure how time limit exceeds. It is not per individual test. It's the sum of all the tests. So it just depends on how lenient or whatever they want it to be, right? So as a result, I just didn't expect them to be this lenient. / I maybe expected a better answer, but yeah. Yeah. Okay. So that's basically the setup. So I just gotta make sure. Ultimately, I just did the bitmask DP. Though apparently it goes by another name, as I discovered on the Discords. Actually I don't remember what the name is because I don't know. I don't think every DP needs a name, to be honest. But that's a aside. I'm sorry. I'm trying to find. My computer's being weird with the shortcuts, so I'm just trying to bring up the drawing board, but it's like taking a little bit of time. But yeah, the idea behind DP, I actually thought it was called bitmask, but apparently not. But so I'm old. I don't know. It's just unnecessary. But the idea here is that you have some numbers, right? And visualization is kind of tricky, but you have some numbers. Let's say you have five, which is of course 101, right? For in binary, that is. And obviously for this problem, we need binary a lot. And let's say we have like 10. I guess that's just actually this. Maybe 11, which is right? I don't know. Right. The idea behind the DP is, well, okay, let's do the DP first. Let's just ignore this for now, right? Is that, okay, you build from the ground up, right, of the max. So the idea of DP sub I, where I is a binary number, right, is that it gives the max where it's tricky. It gives the max where the subset where it gives the max where I is the superset of all the bits used or something like that. Maybe I think that's a little bit awkward phrasing, but I will go over what I mean by that in a sec. Right, let's just ignore that. Right. So what I mean is that, okay, dp and I'm gonna write it everything in binary, right? So dp of 0 is just equal to 0 because there's no number. But let's say, you know, our input we have a 5, right? So we have dp of 101 is equal to, well, 101, right? Because that's the biggest one. Let's say we just kind of throw it out, right? This is actually not throwing out, this is initialization. The idea behind this is so that it's a very systematic way of constructing all the bits so that you're able to get the max using those bits as a superset, right? What I mean by that is that, okay, so let's say you have these, actually there's no overlap at all, but let's say you have dp of 1 is equal to 1, and this is just from the input, right? Then now we can say, okay, well, if we build out this mask, then let's just say there are only 3 digits. So let's ignore this for now. Let's say there are only 3 digits. So you have 0, 0, 1, right? Then now you have 0, 0, 0, or the biggest number is 0, right? 0, 0, 1, the biggest number is 1, right? 0, 0, 1, 0, we don't have any of this number, so this end is 0. And then 0, 1, 1, actually the answer is 1, right? Because this is just taking the max of the components that it can take, right? That's basically what we're trying to do with this. And then next is this, again, 0, 1, or 1. Actually, well, this by itself has a 5, right? But in theory, you also want to take, because this is a superset of this, and also this, then you want to take the max of all those and 5 because it exists. And then that's basically the idea, is that for every bit, I mean, and if you kind of do it naively, this could be very expensive, right? And what do I mean by that? If you do it naively, let's say you have a 1, 1, 1, right? Then now this is, of course, everything is a superset, or everything is a subset, sorry. So that means that we have to take a max of this, dot, 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 all the way, you know, the 3 bits to the 2 to the 3 numbers, or 3 to the 3 numbers. So the key part about what makes this as a dynamic programming is just that instead of checking every subset of this number, right? Instead of checking subset of you know, checking 000, 001, 010, dot, 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 all the way to 1. I guess you don't check itself. I mean, I guess you do check itself in the sense that you pre-populate, but you know, instead of checking all these, what you do is more systematically just do 1 bit at a time. So then this, we actually calculate the max from 110, 101, so just 1 bit off, right? Why? Because, well, if we do it in a DP way, in a deliberate order kind of way, then now, well, this is going to look up 1 bit less, so it's going to be 100 and also 010, maybe not in that order, but you get the idea. And then this one actually merges from 100 and 001. You'll note that there are overlaps, but that's okay, right? There are overlaps, so you may ask, is this why would we do it if there are overlaps, right? The reason is just because the overlaps are bad for 111 per se, but you still, maybe these are helpful for you in the future, which is why we, you know, so this is a way cheap way, or not very cheap, but we'll go with the complexity in a second. But that's basically the idea, is that you just subtract 1 bit, right? And then you keep on going, right? So this goes to 000. I guess they all go to 00 after that, right? But you can see that, yeah. Then now you have every well, except for 00, you have every possible 1 ones and, well, every possible 2 ones. So then it all kind of merges up. So that's basically, or this is, I forget what the term is, but I just call it bitmask dynamic. I mean, it's not the same bitmask dynamic program, but it's another variation of it, if you ask me. But that's the idea, right? The idea is that you just process this tree in a specific order, so that you don't have you save the work here, right? What is the complexity? Well, for each, there are 2 to the n numbers. For each number, there are n bits, and you kind of look up n bits, so it's going to be n times 2 to the n. That's for this complexity. Versus this one, well, this is going to be O of 3 to the n by the virtue of subset things. I mean, it depends on how you want to write it, but it could be either 3 to the n, depending on how sloppy you are. It could be O of 4 to the n, or O of 3 to the n if you're a little bit smarter about bit masks. But yeah, but also clearly this is just slightly better, especially for n is equal to, I think, 20 in this problem. Then this is going to be a 20 mil, which is why, by the way, I did know this, but I was like 20 million, it's going to be very slow on Python, especially that's per test cases. I think they're like 600 test cases or something. So they just kind of have easy test cases. That's the short story, and it's hard to anticipate. But yeah, 3 to the 20 is not going to cut it, and neither is 4 to the 20, obviously. But that's the key part about this one. After that, yeah, after that, that's basically the idea. Yeah, so let's get to it. And this is how it looks in code. This part just, and this is I don't know, it is what it is. It's an optimization, but basically this gets the max number of bits needed, right? So m is the number of bits needed. So that means that, for example, if you have here, you have 64, which is what? Is it 8 or 9? No, it's like 2 to the 8 or something. So that means that that's 8 bits, and it allows us to do, and this is the number of bits. So that's going to be 2 to the m times m complexity. So it kind of allows us to do things a little bit cheaper. But looking at these constraints, you can really suss that out. So I don't know, it is what it is. But yeah, and then this is the initialization. Everything else is a 0 except for the numbers that are in the input, because if they're in the input, I kind of skipped one part. But this is the DP part. Let me actually go back for a second. So how does this help us for this problem? I forgot. I mean, I focused on the hard part, but I forgot about the relatively easy part of the multiplication and everything, right? As I kind of talked about a little bit, the reason this is why we need these intermediate values, so that we could build the entire table, is so that, well, now we want to find something the opposite of it, right? For example, if you have the number 5, then what happens? Well, 5, as we said, is going to be 101. Again, we just pretend that the world only has 3 bits, but that means that we want to get the biggest of the opposite of this, or the inverted of this, which is 0, 1, 0, right? Because that means that we want to get, this is the order. I looked like I drew a robot or something. But anyway, no. It's 0, 1, 0 is the opposite of 5 in this case, assuming that there are only 3 bits. But this means that now this max means that this is all the max of all the numbers that contains this bit, but no bits here. That may contain the 1 bit, but no bits on the 0. And then whatever this number is, you can multiply it by 5 to look it up. And then you try for every number, and you should be good. That's basically the idea. And because there are no overlaps, you don't have to worry about ordering or anything like that, right? Because by definition there's no overlap. So this is the way that I did it. As I said, this is the DP. I set the initial conditions of x is equal to x. This is what we talked about. But we also want to build up to the more bits part, and this is what happens here. We just go from I, and I is the bit mask. The length of the DP is 2 to the m minus 1. Well, actually, the length is 2 to the m, but the biggest bit mask is 2 to the m minus 1. So then here we said b is equal to I. This is just a lot. I'm not gonna go over this because I don't know. This is very weird. But basically, we just get one bit at a time. From I, we get one bit, and then we just do a DP with yeah. Basically, we have this J, right? J is the next bit that we want to um, turn. So yeah, so I is sorry, friends. It is 7:20 a.m. I have not slept yet. This contest was too long for me. This and the previous contest. I is the current bit mask that we're processing. So then J is the bit mask where we remove one of the ones, right? Kind of what we looked at in the diagram or the drawing. Just so J is I minus one of the bits, and this is actually the rightmost bit. I'm not going to explain this one. I mean, you could kind of work it out if you kind of just draw some examples out. I'm not going to explain it. And this just removes the rightmost bit. Also, not going to explain it. Yeah. So you could also work it out. Anyway, but J is I minus the rightmost one of the bits, and then you just do a max over all of them. This is what I was drawing out with the dynamic programming. Maybe this part is wonky, but you could do it with a for loop if you want to be a little bit slower. But I was already worried about timing, right? So that's why I broke out all the weird tricks. But yeah, and then afterwards, then now this is just going for every number. This is what I call the OR mask. So it allows us to flip it to get the opposite, the inverted mask. So you have X, and then you have the biggest number that doesn't contain any bits in X, and you just max over it. So this part is linear, but of course, this part is of m times 2 to the m. This is 2 to the m, and yeah, and this is linear, and that's it. I don't know. I mean, I don't think this is so bad, but the constraint made it so that you have to guess that it is going to be good enough, and that's the part that I spent a long time with. Otherwise, I think this would have been like a, I don't know. I think I got more. If you watch the live portion of it, I mentioned it like a few times. Like I know I could do a DP, and I even I just had it on the screen a couple of times, but I just didn't think it'd be fast enough because you see me like do some benchmarking, and it took like 6 seconds or something without optimizations. I knew I could optimize it, but it just depends on the input, right? Like you can't optimize the worst inputs away the way that I did it, like with here, right? Because this is very input dependent. So yeah, they need a better way to set up the constraints. Like there are only 10 cases where m is, or the sum of all the m's is less than whatever, or something like that, right? Totally ridiculous this far. But that's what I have for this one. Let me know what you think. Thanks for watching, and you can watch me solve it live in the contest now. Analysis isn't so good though for me. Like I didn't do a good analysis on it, is what I mean. All right, let's focus. We have, how much time do we have left? I've only used up about 10 minutes, 13 minutes. A little bit slow for sure, but we can make it up. All right, nums ij such that I times j, or nums of I times, and the binary of them does not share any bits. And it's big. Okay, so n is big. DP. What's 10 to the 6 again? 10 to the 6 is a million, so 20. So each one. No, each one doing a million is too slow. What are you doing? I feel like I should know this one, but. I mean, set intersection is fine, but no. No, not intersection. You said union, right? That doesn't make sense, though. So for each one, we want let's say we process left to right, right? 1, okay, fine. 2, okay, no intersection. That's fine. 3 has intersection for everything, no good. 4, no intersection anyway. I mean, it could be DP. It's just 20 times 20 million is a little bit slow though. Basically, yeah. I mean, maybe. No, I keep on thinking of ways of just like removing them as a query, but no, I mean, we have to do queries a little bit better, right? Alright, let's think about it one bit at a time. Where would I go? So 1 would have to 0. But does this work one bit at a time? No, because it doesn't do the maximization of it. Okay, and then now you have 2, 2, 2. I do like the reverse of it or something. Okay, so let's say we want to look up the reverse. What does that mean? I mean, that's the thing that I was saying about kind of DP, but not really. For each number, can you figure out everything before? Can we even pre-process this in a good way? Or process this number? If that's 20 bit, if it has 20 bits, then that's a lot of numbers, and you can't do it for every number. I mean, it feels try, but I don't know how to do it. Is it just greedy on a try? Am I just being bad today? I guess so. For each number, if it is a 0, then what? Then you look for 1s. If none exists, yeah. Why am I struggling today? It's just a try greedy problem, right? For each number? Okay, fine. Wow, this is such an obvious try problem that I feel so bad about. I have to worry about, I want to worry about optimization. Maybe not yet, it's fine. right? This is technically a node. So yeah, I don't know why I struggle with this one. This is actually pretty straightforward. Yeah, I mean, okay. So then now we just do it by 20, right? So maybe you just start with right, and then now current node is equal to root, and then now if current to x is greater than 0, then we want to go through the path of 1, right? Okay, so now if this is a 0, we want to go for 1 if it exists. So if not, go to 0. If neither of them exist, then we're just done, right? Okay, fine. Yeah, okay. Yeah. Very rusty today. Okay, so if cnode.edges, so if this is a 1, we want a 0. 0 is not none, then cnode is equal to c.edges of 0. Else, if cnode okay, else if it's a 0, and then now else, then we just not found, we break. Right. Otherwise we have a 0. So then now we want to, well, in a greedy way, we want to see if 1 is available first. I could probably write this in a for loop, but I always feel like this is a little bit better. Okay, so then now, yeah, so we went through everything, meaning if current is equal to 0, then we have found it. Well, I guess the found doesn't do anything actually. Then now cnode is the thing. Okay, it doesn't do anything. We wanted a 1, so then current and found is the thing, and then now it's just x times found. Best is equal to max as this, and we are good, and that's it, right? I should have known this one like quicker. I'm just off shape. Unless I'm returning 0 in all of them. Yeah, well. Oh, I didn't insert stuff because I'm a silly boy. Okay. Okay, so that's found, and then now we do it again, but this time, this is a pretty straightforward try, but I wrote this in a really weird way. sort of like an implicit thing on the edges. Yeah, I might see notes. Like system and edge implies the existence of a number. Oh, that edges. So how did that know? Oh, I don't shift. That's actually funny. But yeah, I don't shift. This as well. Ooh, not right at all. Why? Okay, so X found 1. 3 found 1. Is that even true? That's not even right. One of this is not true. Because if this is a 1 and this is a 1, we don't actually go here. We actually break. Because we have a 1, it doesn't even matter actually. Yeah. Okay. Actually, this is an else. If it's 0, then it's fine. Yeah. Okay. Better, but not quite good enough. 2, 1, 3 doesn't match anything. It's good. 4 doesn't match anything. That's good. But max is not a 1 though, right? Max would be the 3. So it should be. So 0, 0, 0, 0, it tries to find 1, doesn't find it, it's fine, finds a 0. But then now when it gets to thing, did I create this wrong or something? Why am I so bad at it today? Because 4 should find a 3. This is a pretty standard problem. Why am I struggling? Okay, so if it's not none else, then this is defined. Is that right? Okay, if it's 0, if you find a 1, go find a 1. If it doesn't, find a 0. Otherwise, neither of these exist, so we break. It doesn't matter, we do. Okay, fine. Right? Yeah, what the hey? Do I not? The creation maybe is tricky though. 1 to the 20. If do we change x? No. If this is a 1, if this is a none, then we set it. Otherwise, oh, this is for the 1. I don't like doing this as much as you like seeing it. I still have to. I have 1 hour and I still have to do Q4. Okay. Something. I don't know. This is the 1. This is the 2. So this is seems to be right. 3. Why is this not finding? Is this weird? This is definitely. Oh well, it's not creating because it exists. So then it's just 4, 0, 0. But why is it not finding though? So creation actually is right. Okay. So it's a 4, so it tries to go to 0. That's true though, right? Am I off by 1 somewhere? It's so annoying to debug too. At least the way that I wrote it. This is 1. Fine. Zero, zero, zero. Three found a 0. That's right, actually. And current is a 1. Should current be a 1? Yeah, because as a 1 as a bit, so it skips the. Okay. Yeah, maybe that's right. Yeah, okay, fine. The 4, why? Because that's a 4 has a 1, so it goes to 0 on a try. But then now after that it has a 0, right? So then it should try to find a 1. Why? Why are you not trying to find a 1? Why are you so lazy? 4. The way I write this, trying just to micro optimize a little bit, it's dumb. Why though? Am I missing something? Man, why am I so bad? It's so straightforward. If it's not none, then you go. If it's not none, then you go. Current is 0 for this, right? Current is 0, but found is 1. You should try to find a 3. Why is this not a... Did I not create it correctly? Am I off by 1 in any way? Current. Shift by 1, shift by 1. Oh, I'm dumb. I don't know what the... There's too many points. How did I miss this? Larry! Usually I use a helper function, that's why today I'm just being a little bit lazy and dumb. Alright. Alright, there's still a print statement though, that's what I'm trying to find. So dumb. Ooh. Actually, don't expect the wrong answer on this one, actually. So that feels pretty bad. Okay. Did I miss something? Because I thought that would be it. C node is equal to root. So we created, okay, file, okay. Okay. So what's the answer here? 0, why? 15 is all ones. 9 and this is 9 and no 9 times 2, so that's just this shifted, right? What is a 9 again? Okay. I have to print some. I don't even know what they are. Well, I don't want to print. Okay. Why is it 162? Oh wait, no, this one and this one. So 9 and 18. Okay. I mean, that's fine. Why am I wrong? Am I doing something else that's stupid? So we break current. We reset current, reset nodes for the... This is so dumb. I'm so dumb, I mean. How? What am I doing? This is such a basic problem. I'm now not happy about this at all. Okay, 9. I mean, yeah. It just doesn't find anything, right? Is my greedy wrong? It tries to do... Maybe my greedy is wrong, actually. because it tries to go down to 15 path or something, or the 15 path, but the 15 does intersect where the 9 doesn't. Right? Let's try to figure out whether. I see. Maybe my greedy's wrong. Then what? Okay. Then maybe I'm just being dumb in general. I mean, it is possible to go down the wrong path. Even though I don't know that. I don't know why this is though. Right? Because this still should go to both of these. It goes to the 1. Oh yeah, no. This does go to the wrong path because then it goes to this 1, but then it's no bueno. So how do I? So it's not a try problem, huh? Even though it took me a long time to debug that anyway. How many people got Q4? I don't. Can I get Q4? Do I have enough time? Huh? Why am I so bad? Wow. Is it just TP? 20 million seems a little bit much though. Maybe it is. Okay, let's try it, and I'll just convert the language if I have to. I thought, okay. I mean, the DP I got right away, but I thought that was a little bit too slow. But we'll see. Okay, so then now, how do I write this? So it is something like for x in nums, dp of x is 0 to x or something, right? And what does that mean? Because you want the opposite of everything. So you want the biggest number that, yeah, okay. I mean, I think that's fine, but and then now it's just for honestly, I don't think this is fast enough, but right. What is the get next bit thing? I forget how to do it. So guys, so yeah, it's something like dp sub I is equal to f max of dp sub I, and then all the previous one, right? So j, right? And then it's just for b is equal to I, while b is greater than 0, then the leftmost bit or the rightmost, it doesn't really matter, but it's just you go to b to or something like this. Or the other way? Is it this or negative? I always forget. No, that doesn't make sense anyway. So, okay. Gives me the rightmost bit. So then now, this one going to flip I by this bit. No, this is J. Right? And we also want to flip it on B. I think that's fine. Or I guess this is also this way of doing it. And then now, yeah, right. Just want to real quick. But this is so slow. Yeah, I mean, this takes 5 seconds and we have 3 numbers. I mean, because it always takes like 20 million. So I don't know that this is going to be cut it. I mean, why don't I know this? All right, we have 48 minutes left. Let's skip to Q4. Maybe I'll come back to it. I don't know. I thought try was a good way of doing it, but maybe that doesn't make sense. Because the greedy isn't true. Okay, well, we have 7 pointers, so that's even tougher. Alright, so maybe today is going to be a rough day. I mean, there's a lot of cheaters on top, so I don't know what that means. But what am I missing? I want to have. I mean, if we're using the try way, we want to be able to. That's actually kind of nice. If we want to go down path only if we know that everything inside that path is good, right? How do I write that in a good way? Everything before is good, but everything after, right? Has to at least a 0 has to exist, maybe? No. How do I do in each node? Can I do this backwards? Can I look at numbers and then no, that doesn't make sense. Maybe I should have done this in the morning and not now. We have 40 minutes. I'm not even close on 2 problems, not only 1. Is there like some sort of DP on the bits? No, because it's any index, right? You could sort it. Does sorting give us anything? I mean, not more than what my try should have done, but it's just wrong on this one, right? Because this is wrong because of the binary bits. Because it forces you to go down to, yeah, I mean, okay. Oh man. Maybe this is why people don't do contests at 4 a.m. I don't know. If it's not try, I don't know. Maybe that's the version. I have to reset. I don't know. It's not try, maybe. Am I just missing something? Draw it out. No, this one you had the visualization. All my ideas with tries don't make it better than n square in the worst case. I don't even know how to handle this case. DP is definitely too slow because it's almost fixed. Q4 is interesting. I want to solve Q4, but I don't even know how to do this one. Maximum. Bits are so weird. There's no. I'm trying to think like of higher power ideas. Oops. still don't get it though. I mean, how is this going to even work fast enough? Maybe this is too crazy. I don't know. Is it you want? I mean, I might as well finish writing it. At least to something to YOLO. Something like do something like that. It's not quite that though. Because you want it for the 20, right? So it's actually. And then it's actually something like that. Right? Does that at least give me the right answer? I mean, it does, but it takes 6 seconds. I'm gonna YOLO submit because just to kind of have it on the thing. But like, there's no way this is fast enough. But am I missing something? Yeah, I mean, I'm not 15. Things. Yeah, at least this one was close, but it's not doing. I don't know how. Maybe this is too complicated. I don't know. I mean, you can't really optimize that much. This is still, this is this is 1 million. I don't know. I mean, maybe you could do some optimization on this thing. I don't know, like I don't know. But at this point, it's just like guessing on the input, right? I mean, this is faster, but it really so much depends on the input that like it's not like I don't think that's yeah. I mean, I guess I YOLO submitted the other one, so I might as well record deal with this one too. But there's no way that's gonna pass, assuming the inputs are actually reasonable. But I don't know. This is like a nutty one. I don't imagine her. What? I was gonna convert it to Java just to see if I could, but this is stupid. Is that intended? Well, I'm just lucky. All right. This is long. Let me just. Just telling ChatGPT to give me long code to convert from before. All right. This is I mean, we had this idea for a long time. I just didn't think that it would be fast enough and with reasonable. Alright, well, at least we have time to play around. Thanks for watching, everybody. Hit the like button, hit the subscribe button, join me on Discord. Let me know what you think about today's problem, this contest, and everything in between. Stay good, stay healthy, take your mental health. I'll see y'all later and take care. Bye-bye.